I'll be talking about velocity time graph in the video lesson today, and I believe that you already know what velocity is. It is the rate of change of displacement of a body with time. And please don't just watch, share with your friends, subscribe, because I'll try my best to do a lot, explain as much as I can topics in physics. So constant velocity, I'm starting with that. I want to draw a graph of constant velocity on a velocity time graph. When you say the velocity of a body is constant, which means you are saying that the body covers equal displacement at equal time intervals. The body covers equal displacement at equal time interval. Then you can say that the velocity of the body is constant. And you can also relate that to constant speed. You see the body covers equal distances at equal time interval. You see that body is moving with a constant speed. Okay, we're looking at velocity time graph. You can also even put it as speed time graph. So the difference is just that speed is a scalar. It has only magnitude, while velocity has both magnitude and direction. So if a body is moving at a constant velocity of, for instance, 10 meters per second, okay, in this case, see the velocity of the body does not change at all. This point is 10 meters per second, which means the velocity is independent of time. After 5 seconds, let's see here, if you check, trace this back to the graph and then to the velocity as is, it stays at 10. So this is the graph of a body moving with a constant velocity of 10 meters per second. And when the body's velocity is constant, we always say the acceleration of the body is zero. The body is not accelerating. Remember that for a body to accelerate, its velocity must be changing, either increasing or decreasing. Of course, when its velocity is decreasing, we say the body is decelerating. So this is a graph of constant velocity drawn on a velocity time graph, which also means zero acceleration. If I will quickly show you this graph on a displacement time graph, if I want to show you the graph of constant let me just link it to this other graph. Displacement is my S. The constant velocity on a displacement time graph is just a straight line. A straight line, you see? This is a graph of constant velocity still, because the slope of a straight line displacement time graph represents velocity. And this straight line that has a positive inclination has a constant slope. So this type of graph has a constant slope. And since velocity is slope, velocity of a displacement time graph is slope, and the slope is constant. So it's logical to say the velocity is constant. But on the velocity time graph, this side is represented. An acceleration time graph, of course, if it was acceleration plotted against time, the graph will lie along the time axis to show that A is zero. Okay, so you can see that on different graph domain, the constant on the velocity time graph, displacement time graph, and acceleration time graph. How about the velocity is not a constant? The velocity increases at a steady rate. At a steady rate. How do you express that graph? Velocity increases at a steady rate. This is velocity, this is time, such that I have this kind of graph. So how will I describe the motion of this body? This body starts from rest because the graph starts from the origin at point O, which is the origin. So the body begins its motion from rest, meaning that its initial velocity is zero. And then because the graph is a straight line with a positive inclination to the time axis, it means that the body accelerates uniformly. In this case, you see the body accelerates uniformly. So meaning that this is a graph of uniform acceleration drawn on a velocity time graph. Uniform acceleration, not constant acceleration. Please take note. Students can most times they mistake it to be a constant velocity. No, the velocity increase because you check out now at time t equals zero, the velocity is zero. Let's see at this point, trace to the time axis is 10 seconds and the velocity is 30, correspond to 30, which means from time t equals to 0 to 10 seconds, or after 10 seconds, the body velocity increases from 0 to 30 meters per second. So the velocity increases, but at a uniform rate. That rate of increase is called the acceleration, because acceleration is a rate of increase of speed or velocity of a body. So when the graph is straight like this, it's a graph of uniform acceleration. The acceleration is constant, and we can find the acceleration from the slope of the graph, because the slope of a straight line or the slope of a velocity time graph represents acceleration. And I can use 2 points. Let me call this one point 2 and call this 1.1, and then I draw my slope triangle. So that change in velocity, that is 30.2, that is my v2. My v1 can be my point 1, which is 0. 30 minus 0 over what is my t2, 10, t1, 0 here. So that will give me 30 over 10. That means the body is moving with a constant acceleration of 3 meters per second squared, So they may ask you in words, describe the motion of this body. The body starts from rest and then accelerates uniformly at the rate of 3 meters per second, and then reached a top speed of 30 meters per second after 10 seconds. The body starts from rest, accelerates uniformly at this rate, and then after 10 seconds, it has reached a speed, that is, the speed of the body has reached a value, a maximum value of 30 meters per second. Okay, and the area under this graph, that one represents the total distance covered. I said that before one of my video lessons. Total distance covered is the area is determined from the area under the graph, and that is the area bounded by this graph line, then this vertical line, which we call the ordinates, and the time axis. So this has a shape of a triangle. So that distance covered, we can use r base times height, and that gives me, so in 10 seconds is r base, my base is 10, from here to here is 10, and the height is along the velocity axis, which is 30 traced to the velocity axis. So that gives me 10 times this is 300 over 2, which is 150 meters. So the total distance traveled, if the body continues like this for 10 seconds, is 150 meters. How about if we're given this type of velocity time graph, and they may ask you describe the motion of the body completely from this velocity time graph. Okay, let me label this graph point O, point A, point B. So you can see clearly there that the body's motion starts from rest at point O, the origin. And the part of the graph OA is a graph of positive slope because of this angle of inclination to the horizontal. So here again, we say that the body accelerates uniformly from point O to point A. So the body accelerates, start from rest, and then accelerates uniformly. At what rate? At the rate of, we can quickly find the acceleration. We can use this point and this point on the graph. 20 minus 0 over 5 minus 0. That will give me 20 over 5. That will give me 4 meters per second squared. So the body starts from rest and accelerates uniformly, reaching a velocity of 20 meters per second after 5 seconds. Now, the second stage of the journey, let me call it stage 2, this stage 1, from A to B, the body's velocity from point A to B, or between times 5 and 8 seconds, is constant, which means the body is moving with a constant velocity of 20 meters per second between point A to B, or the next 3 seconds, 8 minus 5. So, and it means that the acceleration between O and A is 4, and acceleration between A and B is 0, because when body moves a constant velocity, it has no acceleration. So this is a description of the motion of the body in terms of velocity and acceleration. And then now if we have to find a distance covered in 8 seconds, this graph, the area under this graph has the shape of a trapezium. So we can use the formula half A plus B times the height of the shape. So my A are the two sides of the shape that are both parallel. You can see that this side, which is my 8 in length, it is 8, is my B. Then between A and B, I can call that A. So A is 3, B is 8. My A, side A is from here to here, and my side B is from here to here. And the height is read from the velocity axis, which is 20. So with these parameters, I can find the total distance covered, which is having to 3 plus 8 times 20. This is half times 11 times 20. That is, we divide this by, this gives you 10. That is 110 meters. So that is how to calculate the the total distance covered by the body in 8 seconds. Lastly, uh, suppose you are given this velocity time graph of the motion of your body that starts from point O, and then after 15 seconds it's back to point O, because this point C is on the same level, the same point as point O. So how do you describe the motion of this body in terms of its velocity and acceleration and probably the distance covered in 15 seconds? So you can start by saying that the body starts from rest and accelerates uniformly. Why is it so? Because the first part of the graph OA is a graph of constant acceleration, not velocity, because the velocity increases uniformly at a steady rate, because it's a straight line graph at a steady rate of that steady rate is the acceleration, which is calculated from the slope of graph OA, which is 30/6. That gives me 5 meters per second. So this per second square. So this body starts from rest and accelerates at 5 meters per second squared for 6 seconds, attaining a maximum velocity of 30 meters per second. You can see here. And then between this point and this point, or the next 4 seconds, the body maintains the maximum speed attained. That is, it maintains a maximum speed of 30 meters per second for the next 4 seconds. For the next 4 seconds, it moved with a constant velocity of 30. Then from B to C, the speed of the body reduces steadily from B to C in 5 seconds, which means it's like at point B, the driver is close to his final destination and decides to apply the brakes, which will now bring the body to rest with a constant deceleration. So the part of the graph BC is called constant deceleration. And we can also calculate this deceleration using the slope of line BC. Can take this point as my initial velocity. Of course, that's initial. When the body comes to rest at point C, its final velocity is also taken as 0. That gives me 0 minus 30 divided by, this is my point 1, this is my point 2. So I come to my point 2, the time is 15 seconds. My point 1, what's the time? 10 seconds. So that gives minus 30 over 5. That gives you minus 6 meters per second squared. So it's decelerates at a constant rate of 6 meters per second squared. Negative acceleration is called deceleration. And when I'm stating my deceleration, I will not include the negative sign. Please take note of that, because negative acceleration is deceleration. So I'll just put a deceleration of 6 meters per second squared. So that is the journey, the description. The body starts from rest, accelerates uniformly at the rate of 5 meters per second squared, attaining a maximum speed of 30 meters per second after 6 seconds. And it maintained the maximum speed attained for the next 4 seconds, after which the brakes are applied, which decelerates or brings the body to rest with a constant deceleration of 6 meters per second squared. And then the area, which is having the shape of a trapezium, represents the total distance traveled. You can also calculate it using this equation or formula. Okay, so that is how I'm going to end this lesson today. Thank you for watching.